This presentation is an October 2014 update regarding new products and methods BioSculpture Technology is developing in its obesity control division. The customary safe harbor provisions apply to the forward-looking statements which follow. Two-thirds of affluent populations are overweight and one-third are obese. 43% are forecast to be obese in a few years. 7 out of 10 healthcare dollars are spent on obesity-related diseases: diabetes, heart disease, gastric reflux, hypertension, cancer, and sleep apnea. 80% of diabetics are obese. The 2014 obesity medical device market is estimated at $1.4 billion this year. Body fat is compartmentalized. The subcutaneous fat that you can pinch between your fingers that may be unsightly represents 3/4 of the body's fat, but it is the 15% of fat within the abdomen, visceral or belly fat, that can shorten or reduce the quality of your life. The CT scan on the left is a hypertensive male, and the aortic calcifications and nephrosclerosis indicates he is likely to die of a heart attack or stroke. Yet, despite the obese female whose CT scan appears on the right having a larger waist size, she has a much healthier and a much smaller proportion of visceral fat within the abdomen. Subcutaneous liposuction might help that Zoftig woman and cinch her belt, but it can do nothing for the gentleman on the left whose problem is visceral fat. A large waist is a marker for the metabolic syndrome which occurs in 80% of obese patients. It is associated with high blood pressure, a bad lipid profile, and insulin resistance, leading to a high blood sugar and diabetes mellitus. Visceral fat secretes noxious cytokines or cellular hormones, resulting in metabolic syndrome, autoimmune diseases, and cancers. The type 2 diabetes it causes results in lowered energy, is the most frequent cause of kidney failure requiring dialysis, and is a frequent cause of blindness. The accompanying hypertension and arterial narrowing causes strokes, angina, heart attacks, and heart failure. It secretes neuropeptide Y, the most potent hunger hormone known. Mechanically, fat within the abdomen causes sleep apnea and gastric reflux. It shortens and reduces the quality of your life. Bariatric surgery spending reached $1.9 billion in 2013. The 3 common approaches include restricting intake reversibly with an adjustable gastric band, reducing the size of the stomach permanently with a method such as sleeve gastrectomy, or shortening the transit time of food through the gut by performing a gastric bypass. The procedures are most appropriate for patients with increasing BMIs in the following order: banding, sleeve gastrectomy, and lastly bypass, because they result in weight losses, complication rates, and sequelae, which generally increase in that order. Even though laparoscopy has reduced the incidence of serious complications by 1/3, they can run as high as 15% and include erosions, leaks, fistula, bleeding, emboli, fatty liver, kidney stones, and death. Perhaps more significant to patients surviving or avoiding those complications are their accompanying quality of life compromises, such as not being able to eat a normal-sized meal, diarrhea, anemia, poor healing, or easy bruising. The procedures create nutritional cripples who spend a lot of time in the bathroom. Allergan discontinued Lap-Band, but Apollo Endosurgery acquired the declining product line and is attempting to refreshen its image tarnished by the temporary nature of clinical results. We now have some novel, minimally invasive approaches. We have vagal pacemakers signaling satiety to the brain. 2 categories of temporary devices may be inserted by the gastroscope without an incision. Temporary intragastric balloons may functionally reduce the stomach size or delay gastric emptying to encourage portion control training. Intraluminal shunts can shorten food transit time and reduce the time digestive enzymes have to act on ingested food, simulating both the benefits and most likely the nutritional consequences of bypass. 2 single cannula devices, cleared only for subcutaneous liposuction, were used in off-label feasibility tests to remove intra-abdominal fat. Japanese researchers used a UAL probe, an ultrasonic probe, on the greater omentum of pigs in March of 2012 without adverse effects. Andrews issued a press release that it had successfully used its water-assisted system to remove visceral fat on 2 pigs in August of 2013. Neither wand, designed for liposuction, is really practical to stroke up and down through a laparoscopic trocar. BST's EVL device was specifically designed for safe and efficient endoscopic visceral fat removal through a trocar. The company has been granted 2 patents protecting both the device and the method, which involves a reciprocating tube-within-a-tube technology that is gentler by design. Designed for endoscopy, the technology eliminates the need to stroke and minimizes the need to reposition so as to be practical for this application. BST has also been granted a patent for both the method and device for sampling, collecting, and processing aspirated fat to facilitate identification and targeted removal of the most noxious fat first. Direct removal of noxious belly fat with endoscopic visceral lipectomy does not involve cutting into the stomach, bowel, or rearranging the body's alimentary plumbing. No foreign body will be left behind, and it is anticipated results will be permanent. After each procedure, the patient will lose a large multiple of the relatively small amount of visceral fat removed, 7 to 15 times as anticipated. The procedure can be repeated to avoid any weight loss plateau until ideal weight is obtained. This summary of minimally invasive techniques shows that the current regulatory environment favors testing devices overseas and obtaining CE first. Lap-band is a legacy endoscopic device which has already obtained both FDA approval and CE. Disappointing results have resulted in its declining market share and Allergan's divestment. Both vagal stimulators, both intragastric balloons, and one of the intraluminal shunts have obtained their CE before completing FDA PMAs. Inserting a lap-band or a vagal stimulator and visceral lipectomy with either the EVL or the hydrosolid devices are all endoscopic surgical procedures. Insertion of intragastric balloons or intraluminal shunts can be performed less invasively with a gastroscope without cutting. Visceral lipectomy alone is thought to be a permanent rather than a temporary solution. Only EVL is really practical and specifically designed for visceral lipectomy, as it doesn't require being stroked up and down through a trocar. It also does not present the patient with the risk of intra-abdominal hot or pressurized liquids. Efficacy needs to be studied for every one of these new devices. The important question to be answered for visceral lipectomy is how large will the ratio of body fat lost be relative to the relatively small amount of visceral fat removed in each session. Endoscopic visceral lipectomy represents an ideal compromise between the efficacy, invasiveness, and costs. The patient gets the benefit of surgery without the potential complications or sequelae of cutting into the gut or bowel, rearranging the body's alimentary plumbing, or leaving behind a foreign body. There are no implants, no foreign bodies, no pacemakers or batteries with their potential complications or inconveniences. The procedure is permanent, and EVL can be tailored to the individual patient as to the amount and location of visceral fat removed and the frequency or number of sessions needed. We'll first seek pre-market clearance for aspiration of fat, including liposuction for our EVL and a 510K substantially equivalent to our current technology. We'll next do some preliminary testing abroad first, as did the other devices, under an IDE before we address the FDA, to see what will satisfy them for us to get the desired indication we wish in treating obesity, metabolic syndrome, and type 2 diabetes mellitus. Our team has the necessary expertise. I invented both single cannula power-assisted liposuction and twin cannula-assisted liposuction and founded this company on the latter technology. I'm a Cornell-trained and affiliated plastic and reconstructive surgeon who scaled down his practice and obtained a Columbia MBA to serve as its CEO. My medical experience includes heading academic IRBs, and ICOC research animal studies. I'm an attorney specializing in intellectual property with experience in licensing. Deborah Salerno acts as CFO. She has 30 years of securities experience in new offerings and taking companies public. Dr. Ciricilli headed new product development at GE and did the same for BAE Systems programs. He's a University of California mechanical engineer and a Stanford PhD with 4 patents and 20 published journal articles under his own belt. Simon Taylor is a Columbia University John Jay Scholar and Harvard Law School graduate with broad experience in biotechnology and medical devices, startups, ramp-ups, and venture financing. Jack Miskunis is another Cornellian with the Boston University MBA and over 25 years' experience as an investment banker and advisor. He has run several businesses and franchises of his own. Besides being a patent attorney who has successfully prosecuted over 650 patents, Thomas Perkowski is an electrical engineer. Dr. Hughes is a Yale-trained, Harvard-affiliated surgeon who sits on the board of several public and private companies and is also a brigadier general. The entire team has shown its commitment to our intellectual property and business plan by personally investing in the company. I'll be pleased to answer any questions or provide further information. Thank you for your attention.